Hello folks, I'm back again with a video related to integration by parts. So last time we went through some problems related to integration by parts, and what we did was the integrals of the type when you have a polynomial multiplied by e to the x or cosine x or sine x, just one of those three, times dx, the integrals of these type. And remember, for this one, what you basically do was u was your polynomial and then dv was the remaining portion. So it was just basically like this portion, whatever you have in there. So it can be either just e to the x dx, or it's just cosine x dx or sine x dx. So for these type of integrals, this is the method that we apply. Now if you go one step further, now what I really want to consider now is the integrals of the type when you have a polynomial multiplied by ln x dx. Now keep this in your mind that we don't know the antiderivative of ln x by direct integration. So there's a technique that we have to apply to figure that out. And don't forget, the derivative of ln x is 1 over x. So the derivative of ln x is basically 1 over x. So that's what we know. We're going to use that fact. So the natural question now, next one, how can we find the antiderivative of ln x? Because this really comes from integration by parts. So how do we find this? The main point is this. Okay, we don't know the antiderivative of ln x directly, but we know the derivative of it. And if you look at the integration by parts formula for u dv, you're basically using here at the right side a du, which is the derivative of u. So this is used in the second part of the equation. So you may, since we know the derivative of ln x, it's a simple derivative, which is 1 over x, and we know the antiderivatives of all the power functions of the form x to the n or x to the m, x to the r. Doesn't matter what power you have in there. So hence we know the antiderivative of 1 over x, which is ln x. So we're going to use that fact. So here we go. Here we know the derivative of ln x, so I just say u equals ln x, and then remaining portion is dx, so dv becomes basically dx. See, that will make our problem solvable. The reason is this: if I take the derivative of u, that becomes 1 over x dx. If I take the antiderivative of v, antiderivative of dv, that's basically v, and same for dx, so that becomes x. See, now this combination can be integrated easily if we combine them, because the formula was, remember the formula, it was uv minus integral v du. So uv will be x times ln x minus integral v du. So I combine basically these two, so I'm going to get x times 1 over x dx. See, we're done, because this x will basically cancel by this x, and you're going to get x times ln x minus integral of 1 dx, but the antiderivative or integral of 1 is basically x, so I got x times ln x minus an x plus c. So see, this is how we get the antiderivative of ln x. So it's kind of, you may consider this as the integral of kind of like 1 times ln x dx. So still it looks like a polynomial times ln x. So here we go. Another example. This will be more of the first type, like it will be more clear that we are going to get that polynomial in there, not just ln x. But consider this one. Let's say, for example, x cubed plus, let's say, 5x, and this is multiplied by ln x dx. So that's what we can do, and you see this is exactly of the form of an integral of a polynomial times ln x. And I can say this over this example, we're going to observe that every time if you apply this method to any problem of this type, you're going to get the answer. So But of course you may have like complicated type of the problems, complicated types, so you should be careful with those type of problems. But for these type of problems, when you have a polynomial multiplied by ln x, this is the way that you're gonna solve it. So ln x, we don't know the direct antiderivative of ln x. I just say direct. I mean, we cannot find the antiderivative directly. See, we need to use integration by parts. It's a process. But for a polynomial, you always know the antiderivative because it's just basically a combination of power functions, x to the m's, x to the r. So what you're going to do is basically the same format in here, that you're going to call u to be now ln x. It's not like the previous type. You see, in this type, when you have e to the x cosine x sine x, u is your polynomial. Now you switch the roles. So you have u equals ln x, and the dv will be the polynomial times dx. So this is what we will have. And now I can just say here, you see u will be ln x, and then dv will be x cubed plus 5x multiplied by dx. So that's what I got. And now you can integrate this easily, and that one, the derivative of that one, find the derivative of that one easily. Du equals 1 over x dx. And then v equals, you see, x to the 4 divided by 4 plus 5 times x squared divided by 2. So that's what we get. See, the beautiful part is this. If you really combine these two, like the whole function here with 1 over x, you're going to be able to integrate that easily, because that's 1 over x is x to the negative 1. You're multiplying by a polynomial, so you're going to get, since you actually find the antiderivative, you're going to get a polynomial every time for this particular situation. If you multiply a polynomial by 1 over x, you don't really need to be able to get like a polynomial every time, but you're going to get powers of x, so it will be something simple to integrate, because we know the integrals of all the powers of x. So how do we proceed from here? Is again the same way. I got uv minus integral v du. So uv is x to the 4 divided by 4 plus 5x squared over 2 multiplied by ln x minus the integral of x to the 4 over 4 plus 5x squared over 2, and then this whole expression, yeah, times 1 over x times dx. This is what we get now. So now the beautiful part, as I said, you can combine these two, and that will give you another polynomial. Every time? Yes, every time. You're going to get a polynomial in there. So how? Look at this. Because you take the antiderivative of a polynomial, that will not give you any constant anymore. So I got x to the 4 over 4 multiplied by 1 over x plus 5x squared over 2 multiplied by 1 over x. You see, now you can cancel this x to the 4 by this x, and you're going to get an x to the 3rd. And you can cancel this x squared by this x, and you're going to get an x. So this portion, the integral of this portion, will become basically x to the 3rd over 4, x to the 3rd over 4, and then plus 5x over 2 times dx. So I just basically distributed that 1 over x. That will decrease this power by 1, and that will decrease the power of x squared by 1. So we move to the next line by getting this now. So we will have, so we will get x to the 4 divided by 4 plus 5x squared over 2 times ln x. Now if I integrate, I keep that negative in the parentheses. If I integrate x to the 3rd, that will be x to the 4 over 4. So I got 1 over 4 multiplied by x to the 4 over 4. So I put that 1 over 4 out. And then plus, I got 1 over 5 over 2 multiplied by antiderivative of x, which is x squared over 2. And then plus, I have a constant c. So that's what I got. If you can really see, from here I first distribute that 1 over x in here. I got x to the 3rd, I have x, then I integrate them separately. So my final answer, if I distribute that negative to both of the terms, I'm going to get x to the 4 over 4 plus 5x squared over 2 multiplied by ln x minus 1 over 16 times x to the 4 from here, and then another minus 5 over 4 times x squared plus, let's see. So this is what I get as my final answer. You see, like, if you multiply a polynomial by ln x, if you multiply a polynomial, just rewrite it in here. I can erase this part. So if you multiply a polynomial by ln x, if you integrate that one, your u will be ln x. It's just something different than what you have for sine x, cosine x, or e to the x. And the dv will be now your polynomial times dx. As I said, this in the previous video, we said if you just make this choice for the previous type, that then you're going to be in the wrong direction. The reason is this: if you take the derivative of ln x, you're basically getting a power of x, and integration of a polynomial will increase the powers of the polynomial, but that will not affect anything, because if you multiply by 1 over x, you're going to get another polynomial. So that's why this method works beautifully in this type of problems. And as I said before, if you have any questions, you can just write it in the comments. If you want me to solve like different type of problems, you can put it in the comments. And thank you very much for watching, and bye.